Hello world. Man, I'm feeling fantastic. I feel charged. Pumped! It must have happened to me when I hit that button. I feel incredible. I feel like I'm a new person. I feel charged. It was like I was being pulled through parallel realities. I don't know how else to explain it. I feel grounded. Recharged. Stay grounded, kids. Anyway, I feel great. How are you? How are you? Are you doing good? Are you doing okay? Hot buns, look out, coming through! Wow! Woo! Today's video is brought to you by Breadboards. Ah, don't you just smell it? Don't you just love the smell of fresh cooked bread? Nothing like a hot, crispy, crunchy, burnt to a crisp kind of bread. Don't you just love the taste of stale, crunchy bread? I don't even know how long it's been down here. While we're on the topic of bread, let's go ahead and take a look at what else is out there. Oh, look at this. I found a computer under here. Okay, here we go. Let's see. Breadboard. What is this? Wait a minute. What the? Huh? Huh? You gotta be kidding me. Last transmission, I found the skull thing lying on the floor. I have no idea what it is, but it seems to have some working servos and some LED lights that power it. It's a pretty simple build, and I think we can fix this thing together. I've been studying this thing carefully, and I noticed that it has these LED things for eyes. You see that? It's got these LEDs. Looks like it would sit right in there. This thing looks pretty badass. Can't wait to get it working again. I wanted to see if I could test these things to see if the LEDs still work. Looks like we have some positive line, and we have a ground line. In order for electricity to flow, you need to have a positive line and a ground line. Think of the ground line as being like a vacuum in space, and the positive line being something that is matter. This creates a flow of electricity, and that helps to power a lot of your stuff. Breadboards are the most important tool that you need when learning electronics and testing things out that you make. And today, we are going to expose them. I wanted to see exactly how LEDs worked, so I found some extras lying around over there, and this battery pack, and this breadboard, and these wires. Alright, so now this is the part where I show you about breadboards. Everything you need to know to get started, and pretty much everything you're ever gonna need to know. The best way to get this thing started is with a little help from our old friend. That's right, Mr. Maker himself. Oh yeah. It just seems to make it a little easier. Cheers. Ah, okay. Now, time for breadboarding. So here you can see my breadboard. We have what looks like a positive rail, we have a negative rail, and then we have these parts that are marked A, B, C, D, E, just like Battleship when you're a kid. This thing looks a lot more complicated and confusing than it really is. And I'm going to show you because I destroyed mine just to show you. So first things first, let's take a look at what these plus and minus symbols actually mean. This is where you're going to put in your positive and your negative electricity sources, basically. Your ground is going to be the minus, and your plus is going to be your positive, the hot end. Usually it's like a red symbol, right? So that's why we have red, and that's why we have blue. You can use whatever wires you want. Most people end up using red for the positive and black for the negative. This is a full-size breadboard. They come in half and mini sizes as well. I ended up dripping a bunch of solder onto a half-size breadboard, and I had to throw it away. There's nothing that you want to do with a breadboard that's compromised, and they're pretty cheap. They're a couple bucks, If you need one, I got one in the link in the description below. There's a bunch of options, but they're all pretty much the same. They all pretty much look like this. It's just a variation of color or convenience. I just recommend getting at least one full-size breadboard so you can have 2 projects, 2 chips, right? Or 1 chip and then a bunch of other, you know, components and chips that you might want to share it with. You can see I've stupidly put the hard end of the Velcro into the back of mine. The idea was to have this attached to the table or onto the side of a computer or the wall, and I could just pull it off when I needed. The problem is, well, just listen. Yeah, nobody likes the sound of that. So this is gonna get replaced, and I did something to mine just to show you how exactly this works. You can see I've pried it off. All this was a double-sided tape foam pad that they put on the back of here. And when you expose it, look at that. What does that look like? That's a bunch of rails. And these rails are actually not separated. These are one continuous rail that just got punched in. Oh, let me punch the camera. That just punched in at different points all the way down to the bottom. So when you plug in your positive or your negative, which really doesn't matter which side you use, it's just, you know, just colored that way to help you decide. And just for reference, it makes it easier. You can plug one lead in with a DuPont type style wire, which is what these are. You've seen these in every single kit. You need to have a lot of these. Get the medium length or the long length. Don't get the super short length, those are stupid. Alright, so you're going to plug in your positive or your negative or vice versa, and it's going to power the entire rail. So anything that you plug into that rail for positive and anything you plug into negative is going to be connected, and that's a wonderful thing when you have a bunch of things all across your board that you need powered. And I'm not going to show you a bunch of that for the sake of this video, that's just too much. For now, let's just take a look at what exactly these rails look like. So right here you can see one stuck to the back of this dirty, disgusting looking pad that needs to get thrown in the trash. That's about it. It looks like an office clip. This is what's on the horizontally oriented holes that you see here in the middle of the chip. So you have the vertical rails on the sides, right? And then the cool thing is you can jump, you know, you could have a wire that goes from the plus here to the plus here, and they're both sharing the same voltage source. It's pretty easy when you start doing that. So if you're wondering if these rails are long ways and they're all connected, what are these ones? Are these ones, you know, connected all the way to the bottom? No. And there's a reason for that, and I'm going to show you what it is. You can see these ones are only horizontal, and there's a split in the middle. And to show you what they look like exactly, just take a look at what I've got on the back of this. This is what one of them looks like. These individual teeth are just basically little pinchers, and when you stick your wire into them, basically those teeth are what's coming into contact with that wire, and that's going to make your connection. Now the whole row is connected, so everything that you put onto that row, anything that you put onto that row is going to be connected. So if you wanted to have multiple LEDs, say you had, you know, a few of these LEDs, and you just wanted to put them all on the same rail, you had a program that was glowing them or turning them on and off, you could just put them all on the same rail and save a lot of time and a lot of hassle that way, instead of putting them on a bunch of different pins. You'll also notice that there's a break in the middle right here. The reason for that is when you put your chip on, you don't want to connect this side to this side. That would render half of the pins useless. You would be connecting these pins with these pins, basically. You would be bridging the two sides of the chip. So that's why there's that gap in between. And I'm going to show you a trick to get your chips off the board much easier and much safer, because the chips have really, really flimsy and fragile legs that can get broken and bent. Alright, now I'm going to show you a little trick on how to get these things in and out much, much safer, and you'll save some money by doing it this way. And so you can see here I got the legs, right? This is the 328P. You can see how fragile they are by this one that's bent right here. That was just in the case that I had it in, and it gets bent like that. So you just got to be careful, and you got to bend those back and not wear gloves. Alright, so that's good enough. Alright, now we're going to take this and just stick it right onto the board. And you just want to put it anywhere you want. I mean, you can put it anywhere. I like to put it kind of like right there. And then what you got to do is be careful of this side. You got to make sure it's lined up with these holes. You got to make sure both sides legs are getting in there just right. Hey, I got an idea. Let's use a pencil. There we go. Just gonna nudge these kind of to where they're supposed to be. There we go. It looks a little better. And then we're just gonna stick it in. Come on, get in there. Oh man. Don't buy on eBay, folks. Buy it from the Microchip website. You're guaranteed to get it a legit chip that's not bricked. Yeah, anyway, I'm gonna throw that one in the trash. Yeah, there we go. I felt that. Get in there. Okay, so now it's looking pretty good. You can see they're all going into the holes. Alright, so we're ready to mash that shit in there. Alright, that looks great. Good to go. Alright, one thing you need to know is that you gotta have positive voltage coming into the chip, and I like to put it on the rails because I'm gonna use it for other things, like if I wanted to use it for some kind of analog control or something like that, I'd need to have some sort of positive voltage for that. Or if you have some sort of sensor, it's going to need positive voltage. Anyway, a lot of things require you to share the positive voltage. So you could have it coming into here and you jump it to, you know, the row that goes into the chip, and then you could have other things feeding off of that. Or you could have, you know, another cable that's jumping that over to here or anywhere you need on the board, basically. Another tip that I recommend for beginners is to color the pin down in here so that you make sure that you connect to the right pin with the positive and the negative connections. You don't want to get those mixed up and feel like an idiot. Okay, so lucky for me, I'm not going to use the battery source because I'm lazy. I love to use my USB programmer as my voltage source. It's safer. It has special hardware in it and programming in it that allows it to, you know, if you bridge the connection between positive and negative, it's not going to short out anything and overheat your battery pack. It's smarter. It just works every time. So just get one of these. You're gonna need it to program your chips anyway. Okay, so I got it plugged in, as you can see, and I have the option to power the target on. You're gonna definitely want to get a USB programmer that does that so that you can turn stuff on the fly. And from all these leads, all I need is that positive coming into the rail. It can be anywhere on the rail, basically. And then I'm gonna have my ground coming in right here. Boom. Alright, looks pretty good, huh? Pretty easy. Alright, now we're gonna have to jump this over to here. We could put it directly into the chip. Actually, you know what? Let's do that. Let's just put it directly into the chip. Alright, there we go. That's what we wanted. Okay, so from here on, you can put your LEDs on whatever pins you want, and then make sure you have a ground connection onto the appropriate side that goes back to wherever the ground source coming into the board is. And then it should work as long as you have your programming set correctly. That's how you use a microcontroller with the components, and you can power it on your breadboard. Pretty simple as that. And once after that, you can leave it on there like that. You can power it with a battery pack instead of your USB programmer for 100 years. And you could even solder it onto a wafer board or something else more permanent and take it all off of here. It's your choice. Just like I promised, I'm going to show you how to pull these chips off of the breadboard. The only thing that you need is to invest in a $5,000 official Gundam base screwdriver from Journey to Jaburo. You just jam that up in there, and then you put it on this side, and then you jam it up in there, and you flip that shit off. Boom, done. Alright, so let's keep it simple. We're not going to be using a microcontroller just to show you what the breadboard does. You don't need that. All you need It's the supply of voltage. Remember, the leads go this way. All right, and then these ones go this way. We don't really need these right now. We're just gonna put it right into there, and we're gonna have our ground on this one right here, just to separate it nice and good. All right, so here we have what's called a blinking light. This is basically a resistor soldered onto the negative side of the LED. The way that you can know which side is the positive and which side is the negative on an LED is to just look at them sweet, sweet legs. Oh yeah. We're gonna take this LED and we're gonna put it onto the breadboard just to show you how this works. It's very easy. It's easy to get lost though as a beginner, so here you go. I'm gonna put the long leg positive end into the positive rail, and then the negative short end into the negative rail. And there you go. It's basically like water flowing in through here, comes in through here, and it goes out through here. Boom, done. The cool thing about breadboards is that you can connect multiple LEDs and you can test multiple components at the same time. You can move things around and you don't have to worry about soldering. That's why they were invented, basically. So if you take this negative end with the resistor on it and you put the positive end over here, you can see what happens as they share the power. There you go. Look at that. Hey, look, I'm breaking the rules. I'm putting a rusty yellow one behind it. And look at that. How about that? One big happy family. Now let's see what happens if I take this one off. This is the brightest one. Ooh, do you see that? It got a little bit brighter. You probably didn't because my camera sucks. Uh-oh, what happened? I thought it was supposed to work. What's wrong here? Help! Help! Quick, Google! Siri, solve my problem. Did you figure it out? Did you figure out what the problem was yet? I bet you can. That's right. It should be connected to the square right there, right next to it. Bada bing, bada boom. Uh-oh. I messed up. Google, Siri, please save me. What's wrong? Can you figure it out? That's right. They're backwards. Remember, positive end is the longer end and it has to go into the positive voltage source. Boom, there you go. All right, now let's spice things up. Let's put a little push button on there just for shits and giggles. And let's see, we're just gonna put this bad boy up here because he's too fat. Another thing you want to do is be careful when you put in these push buttons. Their legs are also fragile and they have a tendency to break and bend out of shape. So luckily they're a dime a dozen, so don't get too upset about it. Okay, basically this is how it's gonna go. I'm gonna route the power through to this push button first, and if the push button isn't going to be pushed, the connection isn't made and the electricity isn't allowed to flow through it to the LEDs. Alright, so I got the positive end of the power source connected up to my button. It needs to flow through. It's still going to be positive, right? It's still positively charged juice, so it's going to be flowing through here. It needs to make its way through the positive end and bridge over to the negative end. And it needs somewhere to go. So we just put that back into there, just like before. Okay, there you go. That's how you use a push button. Pretty simple, huh? There's different kinds of push buttons, and you can learn how to use them all over at my website. So make sure you check that out. It's actually kind of fun. Alright, enough of that. Let's do one more thing with our breadboard. Let's use a potentiometer. Okay, so we have the potentiometer hooked into the breadboard. Basically 3 leads. You got the positive, the negative, and then you have your variable voltage in the middle. So there we have it. Voltage. Variable voltage. Variable resistor. Pretty easy. You get the idea. We got the eyeball here. Let's go ahead and test it out, see if it still works. Boom. Look at that. That looks fantastic. Mission accomplished. Oh, it looks like we got something coming in. Alright, let's open it up. What is this? Huh. Interesting. Looks like a kind of helmet for like a video game. Really shitty wiring job here. Huh. Battery pack and some LED wires. What a mess. Hey, there's a note in the box. Let's take a look. Dear KimchiRobotics, please fix helmet. The lights don't work. I don't have cash. Take this Maichu instead. Alright. Looks like I work for Candy now. Alright, kid, you want me to fix your helmet? You got it. In the next transmission, I'm going to teach you how to move those servos and what kind of code goes into doing that. This is KimchiRobotics signing off. Stay grounded.